So this is about food substances. It says pupils were investigating the energy content of different foods. They used the following method and equipment. 10 cm cube of cold tap water was poured into a boiling tube and the temperature recorded. A small piece of food was placed onto a mounted needle and set alight using a Bunsen burner. You know, the burning food was placed under the boiling tube until it stopped burning. You know, that's a thermometer, that's the water, and that's the boiling tube, and that's a mounted needle with the food burning food sample, and that's the heat or fire from the Bunsen burner. This is the setup. Are you ready? Then it says, name 2 safety precautions that pupils need to take. Can you mention any 2 safety precautions?
They need to wear goggles.
Yes, wear goggles. So you can write it down.
Okay.
Why should they need to wear goggles?
So that they don't burn their eyes.
Okay, beautiful. Write it in yellow. And then you tell me the other one. What's the next one? Undo. Good. All right, next precaution.
Let a teacher light your Bunsen burn.
But is that a precaution?
What other thing would you do? Because you don't need to wear
Yeah.
gloves.
You have to wear gloves because it's about heat. You need to wear gloves.
Oh. Oh.
Wear goggles to protect their eyes. You can wear gloves because heat is involved. So you need to wear gloves. You know, you need to touch the mounted needle or the boiling tube. Wear hand gloves. Let's specify here, wear hand gloves to prevent your hand from getting burned. You can also wear lab coat. 2 is fine, so wear hand gloves. All right. Okay, that's fine. By the way, this is what we call scientific inquiry. Next, name the independent variable and the dependent variable.
What is that?
Beautiful. Are you ready for that? The independent variable is the variable you need to change first. Now, to determine how it affects another variable, we call the dependent. Can I explain that again? The independent variable is what you have to change, and then you check how it changes another variable, which we call the dependent. For instance, you want to know how the amount of water affects the height of a plant. How the amount of water affects the height of a plant. Did you get that? How the amount of water affects the height of a plant. You know, you need to change the amount of water, isn't it? You can pour for one plant, you pour maybe 1 cup of water every day. For another, you may pour 2 cups. For another, you may pour a quarter cup. The other one, half a cup. So you are changing the amount of water. So that is the independent variable, the one you change first. Then you need to know how it's going to affect the height. The height depends on it. The height of the plant depends on the amount of water. As the name implies, the height of the plant is the dependent variable. So the height of the plant, dependent variable.
Wait. What?
Yep.
I'm confused.
I'm going to explain it properly. Using the example I gave you, we need to know, for instance, let me write a simple investigation. How the height, how the amount of water affects the height of a plant. It's just an example. Which one affects the other?
What do you mean?
Look, the statement, read it out.
How the amount of water affects the height of a plant.
So which one affects the other in this statement?
The water.
Do you mean the amount of water? Yes.
The amount of water.
The amount of water is what affects the height of the plant. So which one depends on the other? The height of the plant, yes, depends on the amount of water. Isn't it? It is the amount of water that determines the height of the plant.
Oh,
Yes.
I understand.
Good. So the amount of water will determine the height of a plant, or the height of the plant depends on the amount of the water. Remember the word I'm using, depends. So which one is the dependent variable? Dependent.
Dependent in the experiment.
Yes, in this particular example I'm using, before we talk about the one we're working on. Which one is a
And the burning food.
No, please, let's use this particular example I'm giving you.
Oh.
Which one is the dependent variable in this particular example?
The plant.
Do you please, when you actually
height
got
of the
the
plant.
height of the plant is the dependent variable. So which one is the independent variable?
The independent variable is the amount of water.
The amount of water. Good. So first of all, the amount of water is what we measure. We change. Like you can start with a quarter cup of water. Maybe you move to half a cup of water, maybe to 1 cup of water, to 2 cups of water, and then you check how it affects the height of the plant. So the independent variable is what we change. I need to write that down. The independent variable is what we change. Independent variable is changed. Okay. So let me put it down here. Independent variable is what we change. Is what we change. I said it is what we change. We first change, is it not? What we change. And the dependent will be what we measure. The dependent variable is what we're going to measure.
In what example? The practical.
The height of the plant, for instance, will be what we measure. when you change the amount of water you're going to pour in, like you assuming for a particular plant you used a quarter cup every day, a quarter cup every day, you will measure the height. For another situation you're using half a cup, half a cup, half a cup, you will still measure the height. So what we measure is the dependent variable, but what we change is the independent variable. So the independent variable is like the input. In maths we call it input, which is usually on the x-axis. Input on the x-axis. That's why the independent variable is usually plotted on the x-axis. The dependent variable is the output, usually on the y-axis. Output on the y-axis. Alright, so in this particular investigation, remember what we're investigating. Can you scroll up and read the investigation?
The method.
Pupils were investigating the energy content of different foods. The energy content of different foods. Let me underline it because that statement is important. The energy content of different foods. So, the energy content of different foods. So let's go now. What's the independent variable? Or what's the dependent variable? You can start with anyone. Scroll down and get the answer. I've underlined it already. So what's the... Okay, maybe it didn't show immediately at your end. Okay.
So
What's the independent variable?
the independent. So would the independent one be the one that
We change. Remember?
change? So wouldn't that be the burning food sample?
Good. The one we change is the independent variable. So that's what? Again? Say that again.
The burning food sample.
Or the food samples. That's correct. So that's the food sample. That's food sample. You got it. So that's food sample. So don't worry, I'm writing it down.
Oh.
Just undo. Good. So what's the dependent variable?
The dependent variable is water. Is it water?
Are you sure? Is it water that we really measured? Read the investigation again.
Pupils were investigating the energy content of different foods. Wait, the following method and equipment.
Mm-hmm.
10 centimeters squared of cold.
And they recorded the temperature. Remember what we measured? Remember I told you the dependent variable is what we measure. So what did they record?
Cold tap water.
Record what they recorded.
Temperature recorded.
So dependent variable should be what? What they measure?
The temperature recorded.
Temperature of the water. Basically what they are trying to check is the amount of energy. So temperature of water to determine the amount of energy, if you like.
The temperature.
I've written it.
Oh.
Determine the amount of energy. All right. It says explain 2 ways the pupils could change the method to make it a fairer test. I need to talk about fair tests. Fair tests. Are you listening to me? Fair tests will be what you need to do, as the name implies, so that you won't be biased. Imagine I want to check how the amount of water, like this investigation. Scroll up a bit and let's read this investigation I started. How the amount of water affects the height of plant. By the way, you told me in this investigation height of plant is dependent. Let me write, yeah, dependent variable. Height of plant is dependent variable. And amount of water which determines it is the independent variable. Is that not what you told me? If you're going to carry out this investigation so that it will be fair, you have to make sure that you're not biased. So I'm talking about this investigation here. If it is how the amount of water affects the height of plant, the only thing you should change should be the height of plant. Oh, sorry, the only thing you should change should be the amount of water. Let me explain. And then, for instance, you can use a quarter cup of water every day, while another student uses half a cup of water every day. That pours half a cup of water to his own plant. Then another student pours a full cup of water. Another student can pour another quantity of water, another amount of water. But to make it a fair test, all of you should use the same kind of plant. Plant. You have to use the same kind of plant, because if you don't use the same kind of plant, if someone uses a plant that naturally grows taller than others or grows faster than others, it will be unfair. It will be an unfair experiment. It's just like, let me give you an example. If I want to know who are more or let me say who is more intelligent, or who are more intelligent, boys or girls, what do you think I can do to carry out this kind of investigation?
Make them do a test.
Make them do a test. Good. So to make it a fair test, what do you think I should do?
Well, the tests have to be the same.
Excellent. It has to be the same standard test. Same type of test.
Oh, so to make this a fair test,
Yeah.
you have to have the same food.
No, it can't be the same food, because we are basically changing the food. But hold on before you conclude.
Yeah, but then when you change the food.
There is, well, please, hold on. Let's conclude what you were talking about, the investigation, or to know who is or who are more intelligent, boys or girls. So we need to give them the same kind of test, isn't it? We need to make sure they are of the same age. It will be unfair. It will be unfair to use a boy of say 2 years or 3 years, and then a girl of say 10 years, of course, who is probably in a higher class. They should be of the same age. They should be prepared by the same teacher now. Don't you think so? If possible, they should be given the same kind of food for some time, because there are certain food substances that can make people sharper or reason faster. Maybe milk, food with certain minerals. So all of those things you have to make the same, so that you won't be biased, are called control variables. You must keep all the control variables the same to make your investigation a fair test. I'm going to write it down up here. So what I'm saying is this. I'm going to write it down up here. Go scroll up a bit. Yeah, control variables. These are, you see, the control variables are every other thing that can affect what you are investigating. If if it can affect it, then you have to keep it the same. Let me explain again. These are other variables that can affect the investigation, so must be kept the same. In order to make it a fair test. For instance, the case of boys or girls who are more intelligent, we want to use a test, a test to measure that, is it not? And maybe an IQ test, is it not? Okay, the IQ test is what we want to use. But we must make sure that every other thing that can affect the test must be kept the same, like their age. Every other that can affect the result must be kept the same, like their age, the amount, the type of food they eat, the kind of teacher that prepared them for the test, maybe even their background. You know, some people might just be naturally intelligent. That doesn't mean that every other person should be as intelligent as they are. You know, things like that. Okay, please, so that we don't overemphasize this. For this, scroll down a bit for this particular one I'm using before we go to the main question. For this particular one I'm using, this example, look at it below. So for this investigation, read out what it is again. How the amount of water affects the height of plant, isn't it? Is there any other thing you know that can affect the height of the plant? Apart from the amount of water.
The amount of sunlight.
Yes, good. Beautiful. The amount of sunlight can affect the height of the plant. So to make it a fair test, they should be exposed to the same intensity of sunlight. Same intensity of sunlight. So I can just add the control variables. That's so beautiful of you. So let's look at the control variables. You say the control variables for this investigation should be A, amount of sunlight, right? Amount of sunlight, because it can affect it. B, anything type of plant, because certain plants can grow taller than others, so we have to use the same type of plant. So if I say amount of sunlight, it means they must be exposed to the same intensity of sunlight. So type of plant, amount of oxygen, no, amount of water is what we want to change. So amount of, you're not going to talk about the amount of water, we will eventually change it. But every other thing that we must make sure is the same for all. Investigation must be kept the same to make it a fair test. So amount of sunlight, you can even include amount of carbon dioxide, because those things can affect, because that is necessary for photosynthesis, right? Amount of type of plant, amount of carbon dioxide, you know, CO2, even temperature. Do you know certain plants may not grow very well in very cold regions? So amount of temperature. EDC, weather condition and all of that must be kept the same to make it a fair test. Alright, so let's look at this question. Pupils are investigating the energy content of different foods. So in this experiment, scroll up so that you see what I'm talking about. You, in this experiment, what are the things that should be kept the same, like they are, to make
The
it
amount
effective?
of water.
The amount of water, yes. We need to keep the amount of water the same because we are measuring the temperature. We're measuring the temperature change. Remember, the thing is, he started by measuring the temperature before and after. I think it was stated there. The end temperature was recorded. Let me see. I think the initial temperature was taken. The initial temperature must have been recorded. Okay, yes. The cold water and the temperature was recorded at first. Let me give you what it will look like. Assuming it started with a room temperature of 20 degrees Celsius. Please, are you seeing what I'm drawing? What I'm circling. Can you see what I'm circling? We started with an initial temperature of 20 degrees Celsius. Before we lit up the Bunsen burner with the food substance to heat up the water. Now, after we've lit up the Bunsen burner and then we burnt the food completely, the temperature of the water must have risen. Assuming the temperature of the water rises to 45 degrees Celsius, the end temperature is now 45 degrees Celsius. What's the change in temperature, for instance?
Change in temperature.
In this case, the temperature change. What was it?
Increase.
It increased from what to what, and by how much? That's what I mean by temperature change.
It increased from 20 to 45.
Which is by how many? That's 45.
Which is 20 from 25.
25. So the temperature change will be 25 degrees Celsius. For example, assuming we use a particular food substance, e.g., so we do the same thing for, assuming we use them, there were 3 food substances that were used here. All right. So I said we did that for minerals, for instance, and we discovered that the temperature rose from 20 degrees Celsius to 45 degrees Celsius with a change of 25 degrees Celsius. And we tried this, we repeated the experiment with fats, and we noticed that the temperature rose from 20 degrees Celsius to maybe 80 degrees Celsius. That's a change of 60 degrees Celsius, because 80 minus 20 is 60, just like we did 45 minus 20. If it is fat, we will do the final temperature, which is 80 for fat, for instance, minus the initial 20. So that will give us the change in temperature. Then we repeated the experiment with protein, assuming protein changed from also 20 degrees Celsius to 60 degrees Celsius. From 20 to 60, the change will be 40. All right, that's the way this thing is done. And so, explain 2 ways the student they should change the method to make it a fair test. All right, you've said it should use the same amount of water, is it not? Use the same amount of water, because if you use different amount of water, it may affect the temperature rise. Use the same amount of water.
And then you need the same amount of food as well.
No, you can't use the same amount. Oh yeah, the same amount of food. That's very, very correct. Very, very correct. Very, very correct. It has to be the same amount of food. The only thing that will be different is the type of food, is it not? Beautiful. Same amount or same mass. Same amount. Wow, that's very intelligent of you. Same amount or same mass of food substance.
So Joe, when it's asking, in the question when it's explain 2 ways that people could change the method to make it fair. But isn't the method already fair?
We didn't know if he used the same amount of water. Was it stated there? If it was stated, then you talk about something else. But if it wasn't stated, then you talk about it. We were not told if you use the same amount of water or the same amount of or mass of food substance. So every other thing that wasn't talked about in the procedure, you need to mention it. All right. So it has to use the same amount of water, which will be 10 centimeter cube every time. But it wasn't stated, so you need to state it now. And I think you should also try using the same starting temperature. You should make sure that the temperature for the start should be the same.
The temperature for the
Same
start.
same
What do
starting
you mean?
and room temperature. I will explain. All right, I said you should use the same starting temperature. Did you hear that?
Yeah.
Because that can also affect it. It's a bit slightly beyond your scope, but it's something that needs to be done. Same starting and room temperature. Because what was the starting temperature I assumed?
The starting temperature.
I assumed in my own, pardon, 20
20
degrees Celsius.
degrees.
Like it could have been the room temperature when the investigation started. If someone did it maybe in another city with a different starting temperature, it might affect the readings because there's a way those things happen. Temperature difference can affect how much heat is transferred or absorbed. But leave that for now. It's something you will learn much later. All right, so these are the things you are asked to write only two, so you can use the same amount of water, use the same amount or mass of food substance. Now, number 4. What is said in number 4?
Number 4.
Question number 4.
It says, of the 3 nutrition groups, minerals, fats, and proteins, which would have the highest energy?
So, which one has the highest energy of the 3 nutrient groups? So, like I said, food substance, you can say, or food nutrients. So, which one do you think will have the highest energy group? Like, which one will produce the greatest rise in temperature? That's how we know the one that has the high energy group. Which one will produce the greatest rise in temperature?
Fats.
Fats! That's beautiful. That's correct. Fats, because it has a lot of energy. So, fats. Yes. So fat will produce the highest change in temperature because it has a higher amount of together with carbohydrate. Carbohydrate is an energy giving food. Okay. So that's for scientific investigation or what we call scientific inquiry. Usually, are you listening to me? I told you, usually in an experiment like this, we plot the independent variable on the x-axis. I need you to draw a graph under where I wrote control variables. Let me explain this and then we can.
Draw a graph.
Yes, under here, on that space where we have yes. Draw a graph. That's what I mean by draw a graph is a y-axis and an x-axis. Yeah. Good. That's correct. On the x-axis, which is down, write independent variable on this x-axis. Independent variable. That's what we normally plot on the x-axis, except they ask you to plot it elsewhere. Independent variable. That's x. On the y-axis, write dependent variable. Write it a bit come up a little bit. Come up a little bit. So write dependent variable, yes. Okay, just write it the way you were trying to write it. It looks like you were trying to bend your hand, but you don't have to bend your hand. Just write dependent variable. Come up a little bit. Yes, a little bit. Dependent variable, yes. Yes. So that's how it is. Usually, if the graph, I want you to draw, give me a second, let me refresh my Jamboard very quickly. Okay, I can zoom in. Very quickly. Usually, this graph you drew, if I have a line that runs like this, so let me draw it very well. If you have a line that runs like this, it means that as the independent variable increases, the dependent variable also increases at the same rate. That's what this thing means now. As one increases, the other also increases at the same rate. And so we say one is directly proportional to the other, but that's a little bit beyond your scope. Let me call here A and call here B. One other thing I just need to add is when you draw a graph like this, please, this one you need to pay attention to it. You need to pay attention to it. Let me use something like, I'm trying to stretch a piece of wire. I'm trying to do what? Stretch. You know, I will change the force and then I will check how much it has extended, how much it has stretched. Is it not? So what should I change first? The force. Extension, maybe in centimeter. I will change the force. Like I might apply 20 Newton and then I check how much it has stretched. I change it to 40 Newton, then I check how much it has stretched. 60 Newton, I check how much it has stretched. And so on. The one I change is usually on the independent variable x-axis. What I'm going to measure, like the extension, will be on the y-axis. Whenever you plot a graph, that quantity must be written there with its unit. The quantity plus the unit must be written there. Like force in bracket unit, it must be shown there. Like extension in bracket centimeter. You might decide to put it in bracket or use a slash, it's the same thing. Is it looking a bit confusing? No. Let me show you what I mean. No, there's nothing confusing about this. Let me just show you. And that's the same thing I said must be done when you are putting it in a table. Let me just show you what I mean. So this is what I'm saying. Assuming you had a string or a rubber band, right? Then you start stretching it by applying a force. Let's even start with a force of 20 Newton. and then the rubber band stretched by 5 centimeters. You recorded. Then you increase the force to 40 Newton. The rubber band stretched by, say, 9 centimeters or 10 centimeters or even 10 centimeters, you recorded. And then you increase the force to 60 Newton. The rubber band stretched by, say, 15, and then maybe to 80 is stretched by 20. You know what I mean by stretching? Like it gets longer by 20 centimeter, and then you increase it to 100 centimeter, to 100 Newton, sorry, and then it's stretched by 25, just for illustration. So what you are changing is the force now, is it not? I mean, what you have to first change is the force. So the force is the independent variable. And you know, we always plot the independent variable on the x-axis, this horizontal axis. Then you measured the extension, how much is stretched. The first 20 stretched by 5, second stretched by 10, third stretched by 15, fourth stretched by 20, 100 stretched by 25, and so on. So all of these ones we measured are the dependent variable, the extension, which you plot on the y-axis. Dependent variable on the vertical axis or y-axis. Independent variable on the x-axis. So the point is this: even with the table, whenever you draw a table, the quantity must be written on the heading, like force, and then you show the bracket, show in bracket the unit. What's the unit of force?
Force 20.
The unit of force is Newton.
Oh, Newton.
So that Newton must be shown. What's the unit of length? You can, like centimeter we use, that unit for the extension must also be shown. So the point I made is the quantity and the unit must be shown in the heading of the table. Because it is already shown there, you don't have to be repeating it in the table. You don't have to be writing 20 Newton, 40 Newton, 60 Newton, 80 Newton, 100 Newton. There's no need. You don't need to repeat it in the table. And you shouldn't, because you've already shown it in the heading. The same thing for the extension. How much is stretched? You've already shown that it is in centimeters, so you don't need to write centimeter all over. That's why you must show the heading of each column, the quantity, which is force, in bracket the unit. You cannot even use slash the unit. It's the same thing. And that's also the same thing you will do for the graph. The quantity must be shown in bracket the unit or slash the unit. For the x-axis, independent variable, the quantity must also be shown for the dependent variable with its unit. This is the independent variable. Sorry, let me write it out so that it can come out better. Independent variable. And then this one is dependent variable. The quantity extension must be written there with its unit. It's also good to make sure that this is done. So that's all. If you have a graph that goes like this, it means that as the force increases, the extension also increases at the same rate. That's what it means. When one increases, the other also increases. That's all I wanted to tell you. Did you get that? But if the graph goes this way, let me just show you. Look at the red line. Has it shown at your end?
Red line?
I just drew a red line now. On the graph.
Yeah.
What does this red line mean?
The extension going down.
Good. Something like this. As the force increases, the extension is decreasing. That's what this red line means. So I will just write that down. Please, I will just write that down and then we end. Red line means as the force increases, the extension
I'm coming.
the extension decreases. As the force increases, the extension decreases at the same rate. Sorry, at the same rate. That's what red line means. The black line means as the force increases, the extension increases. Let me write it on top of it. As the force increases, the extension increases at the same rate. Please just read it and then we are done. I said the black line means what?
As the force increases. When the force increasing.
Just read what I have written. Oh, it's not, it hasn't shown at your end. Hold on for it. Hold on for it. It needs to show at your end. Just a moment. It should come up at your end.
Wait, did you write as the force increases?
Yes, it's yet to come up at your end. What I actually wrote is coming. It's yet to show at your end as the force increases.
Yeah, shown on the black line.
But it hasn't come. It hasn't come on fully. As the force increases, the extension increases at the same rate. That's what I wrote. What I wrote for the red line, did it show? The description for the red line. Read it out.
Yeah.
Read that one out.
As the force increases, the extension decreases at the same rate.
Say this. Say it, but now using what the black line means when it's sloping up. As the force increases for the black line.
As the force increases for the black line, the extension decreases.
No, the extension increases. That's for the black line. Both of them are increases. You see, when it's sloping upwards, as one increases, the other also increases. All right. Just like when one doubles, the other also doubles. Look at the table. Okay, see, it has shown now. Can you read it now? It has shown at your end. I can see that it has shown.
As the force increases, the extension increases at the same rate.
Now, look at the table. You see that when force increases from 20 to 40, check what the extension did. What did the extension do?
20 to 40.
When the force increased from 20 to 40, what happened to the extension?
The extension increases.
From 5 to 10. So when force doubles, extension also doubles. When force doubles, extension also doubles. So as force increases, that's the black line. Whenever it is sloping upward like the black line, that's what it means. All right. So I think that should be fine. Okay.